Okay, Javier, here we have a new experiment. So basically the idea is that we have a new XPO provider. In this case, it's a modified provider for JSON. So I was thinking like, okay, like sometimes you need to handle JSON. Now, like these days, everything is JSON. Like long time ago, it used to be XML, but right now the communication through the network is JSON. And you get it really often in many languages like JavaScript and of course .NET. So, well, I was thinking, how can we use this with XPO? So it ended up being like easier than I thought. So the idea is that you create a, a modified provider of the original SQL Server provider. And in this case, we're doing something really simple, just creating a JSON column when we have this name on a class. So let me show you the class that we have here. So let's go
That
here.
Jose, in this case, we have a hard code, but we can put an attribute, or we can.
Yeah, I did it because it was an experiment at the beginning. Then I went crazy and I finished all the functions. So it's not an experiment anymore. I guess we will use this at one moment or the other. But at the beginning, I just put it hard code to move faster. So of course we need to fix that later. So I created this class. It's called Json Storage, and it's really simple. Just two properties. One is an ID that is actually it's not an ID. I just put an ID just to have something to easily know which record I have instead of a no ID, of course. And then JSON data, which this will be basically a JSON column in the end. So let me delete everything so you see from the beginning what will happen. So I have this, and let me delete the table. So let's delete this one first, and this one also. And okay, it's empty. So let's see what happened. So okay, we have the modified provider that is like, as you saw, it's like really easy, just an override. And then we have this simple class. So far, so good. Like not even like 20 lines of code so far. So let's go and check the unit test. In here, I'm doing like this. I'm tired to repeat this in every, or I guess people is tired of hearing me saying this in all the videos. Best practice number 7. Update your schema using XPO. So this is the code that I always copy from that article. So basically we register the provider, then we create a connection string, then we basically create a data layer, we update the schema and the object type records. We create some data. So let's go here. And let me show you what I have in the data classes. So basically we have a POCO class. First name, last name, country of birth, country of residence, and a nested object just to make it more complex. So it's not like super simple example. It's kind of like normal complexity example. So the address info is basically another class with country, state, and street. So again, also kind of flat class, but if you compose them both, at least you have 2 levels. So in here we have 2 persons, of course, that the person that I use in every example, so you and me, and the data. So my name, last name, country of birth, country of residence, and my address. And then the same for you, name, last name, country of birth, country of residence, and address. So we have these 2 POCO objects in general instantiated. And then we create some another POCO objects that are different, because the beauty about this is that when you store JSON in a column, you can store any JSON. It's not about having a schema for it or a certain amount of columns or data types. JSON is JSON, and you can store any JSON that you have. It's big, small, nested, you name it, you can store it. So you can get it from a string also. I did this because it's the normal way that you will do it in .NET in general. So Then basically we make a collection just to delete everything. So every test when we start is totally clear. And then we create a Json storage instance. And we pass the ID, it's hard code, just to figure out which records are we seeing. And then to the JSON data column or property, we just serialize the object that we have, and we pass that as value. And the same goes for the other record, for the country record from the language lookup. So far so good. And then we commit the changes. So let's run test by test. Some of them are almost the same case, so we will go fast through them. But let's start with this one, and let's just run it and stop it here, so you can see everything that happened when the database was created and updated. So I want to show how the table is created. So here is returning since the column name matched JSON data, it's returning this, which is the SQL instruction to create that type of column. And let's return. And so far so good. So let's see it here in the console. So basically, see the inserts. We are inserting basically JSON objects in here. So that's really nice first. But JSON objects basically a text in general. So let's see what we have. I told you that we register some functions, right? So those functions are the functions that are provided by SQL server to handle JSON. So the first function that we're going to use is called Json simple equal, and this is made up by me, because sometimes you just want to check if a property is equal to something, and that will return a match in general. So if we go to the database and refresh here and check this table, so we have the ID and the JSON, right? So let's check. We want to get the one that in the JSON data column, the country of residence is USA. And if you see, there is no operator, there is no equal operator, because this it means always equal. At least that's why we call it Json simple equal. So this means that if I get a match from here, it will be basically you, because you are the one with the country of residence USA. So let's see how it happens. I mean, how it goes. So continue. So this is the operator that's going to be created. And then we will create basically an XP collection. So far so good. It didn't explode in any place. And let's just go through the records. And the record that found was basically you, ID number 2. And this is the JSON data that was stored in the column. And if we check the count of the matches, it should be just 1. So it was 1. And this test passed. So far so good. Like, really nice, right? You can store JSON data and then use it in the criteria conditions, basically, with the criteria operator parse. So
hey, Jose,
let me show
can
you.
Can you show me the JSON simple equal class?
Yeah, of course. Here is the example that I used in the documentation, and it's really simple. Basically, you just need to implement an interface. This evaluate is the evaluate that happens in the client side. So it's not implemented here because we're using a database function. So this is when you want to use a link query, for example, that is already on the client side, or if you want to use a filter where the objects are already loaded. So in this case, it's not needed. You can implement it, but it's not needed because we're using the database engine for that. So the name of the function is basically the name of the class. Then what we're going to return is basically a string. And then in the format function, basically we check if the provider is the provider that we have. So you register functions per database engine. You don't want to register a function that is for Postgres in SQL Server. It will not work, basically, even if you can create a valid SQL for it. So you check this, and if it's not this one, of course, you can throw an exception. But if it is, basically, you just format the JSON function that the database provides, and that requires basically the name of the column, the path to the property, and the value that you want to compare.
Evaluate.
Yes. So that's basically, this will be sent, and I think it's here in the console. So you can see the query. Yeah, it's here. See,
Yeah,
where GC record is not null and JSON value. We pass the column, we pass the path, and then we pass the value that we want to compare it to. So
nice.
it basically execute the function. So that's what we did with all of them. So let's go through them really quick. So that's the simple equals, because I was lazy to put equal all the time. That's why I create that simple equal. But then you have the JSON value, which is basically the same idea. The only difference is that in here you have to write the type of operation that you want: equals, greater, less. You can use like database functions that are like substring or something like that. But to make it simple, I just use equal in the end. So the same idea, we will get the records, any of the records on this table, where there is a property called country of residence, and the value is Russian Federation. That's what I leave. So if we do this, we will check the query and see country of residence is the same type of query, equals Russian Federation, and that will basically retrieve me. And let's check the console. Yes, of course, I'm here with ID 1. And what I think is really nice about this is that all these JSONs are different schemas, different structures, and still you're able to do a query as long as you know the path of the property. So that's really nice, because to store it is easy, but to query with evaluating the JSON is what I found like magical somehow. Then another example. Okay, sometimes these two examples that we have are like basically too simple. We want to do something that is more complex. So in this case, we are using JSON value, the same function that we registered before, but the path of the property is more complex. So
yeah, as you can, one level deeper.
One level deeper. I mean, and you can go as many level deeper as you want, because in seeing here you have the property address, which is another JSON object with country, state, and you can go deeper than that. But it's like at least 2 levels of complexity or objects. So let's run it. This will retrieve you again. So yeah, let's see the query. JSON value, address state equals Arizona. And we have here Javier. So, nice. So far, so good. And the last example is sometimes basically you want to get the record that match and also get part of the record that match. So let me show you the last case. In the last case, we have this type of values, right? For example, imagine when you need to represent a combo box or a lookup in a mobile application. You usually send the data, and then you have to send the selected value, right? The one that it will be on when you open that view or that screen. So in here we have this object which contains one property that is a string, the selected value, and then it contains an array of values. So in this case, I will use the combination of two functions. Basically, I will use Json value to match something. So to match where selected value is equal El Salvador, for example. And then I want to get a piece of that object. So the piece that I want to get is the array of values. So you can even get part of that as results. And that is, I think, is even something like super useful in the sense that, of course, if you see the object that we have, the Json storage, is really simple. Only ID and the JSON data property. And it will be impossible for us to create more columns here on runtime and represent it as a class or something. But at least what we can do with the magic of XPO is create a XP view and get that part of the object as a column. So see this. Basically, we're going to query the object. What we're looking for is where selected value is equals to El Salvador. And then we create an XP view. We get one of the properties, only one ID. And then we another property. We want the values. So these are the name of the columns. This is the ID column. And since I don't set a value for, I mean, that's the column name. And then one is the column that is represented in the database, right? So if it's the same, you don't have to put both. But in this case, I want to name the column in the view values. And what I'm going to execute is one of the functions that I created. So the function will get from the column JSON data the property value. So this will return an array in general. So let me show you the function. Let's see what it is. Json Query. So let's see the evaluation. That's the only thing that we need. So I execute the native function of the SQL server. I pass the column that I want to evaluate, and then I pass the path that I want to get the values from. So that's basically it. It's kind of really simple, right? So let's run this. Let's put a breakpoint here. So this is the criteria that we're going to evaluate. So, and then the columns that we're going to show is ID, which basically is the same ID as the object. And then we will create a column named values. And for that, we executed a function. So see, this is the query that was executed. So see, it changed the select. You're not using only the functions for the where, but you're using the functions also for the select. So see, select ID, and then a JSON query that will be the values from Json storage. And then you again, we again use the function JSON value to match the record that we want. So the result, if you see the console, is the ID number 3. And then in the column values, we get an array of strings. So it's really neat because you can get any part of a JSON that you need with this. So basically, you can create like really complex objects that you don't need to use JSON handling like with, for example, Newtonsoft from JSON.NET or System JSON. So the database handle it for you in general. So in this case, we have implemented almost all the functions that SQL Server use to handle JSON. There's only one that we didn't implement, that is, I think, is JSON modified, because we don't need it in the end. It's to do updates on JSON, but we want to just query them and being able to insert them. So far so good. And any thoughts about this, Javier? What do you think about it?
No, I think this is awesome, especially because we not have to go to the SQL server layer. We do everything through XPO. That is what we like. And not only that, I can see a few use that we can get out of this, maybe in IoT type of application, or I will find some use for this provider for sure. This is this is really
Yes.
nice.
So this is what we have, guys. And if you found this interesting, just write us in the comment. We're always looking forward to make some experiments. And actually, after making this, I was so excited about it that I double checked the Postgres function for JSON. And they have like, it's more extensive. In here in SQL Server, you have like 3 functions. In Postgres, you have like 20. So you can do even crazier stuff. I will do another example, like maybe next week, for Postgres, because I think the JSON handling of Postgres is ultra powerful. So let's see what we can get from there.
All right, guys, thank you for watching, and see you guys in the next video.